Welcome to our Enhanced Science 9 Force, Motion, and Energy class. Today, we will be having the following competencies. Relate impulse and momentum to collision of objects like vehicular collision, and infer that the total momentum before and after collision is equal. To start with, let us discuss the following terms: momentum, impulse, change in momentum, impulse change and momentum relationship. Let us first have momentum, which has a symbol small letter p. Momentum is inertia in motion. When you were in grade 8, we discussed law of inertia, and there are two conditions for law of inertia: inertia at rest and inertia in motion. Mass is the measure of inertia. So when the object is in motion, it has mass and velocity. Mass and velocity are the factors that affect momentum, because momentum is the product of mass m and velocity v. The unit for momentum is kilogram meter per second. And since momentum is affected by velocity, it follows the direction of the velocity. Thus, momentum is a vector quantity. If the object is moving to the right, the momentum's direction is to the right. If the object is moving to the left, the momentum's direction is to the left. Let us apply the concept of momentum in this sample problem. What is the momentum of a ball with a mass of 2 kg and a speed of 3 meters per second to the right? Feel free to pause this video in order to write your answer in your notebook. Using the equation P is equal to mv, we can substitute 2 kg for mass and 3 meters per second for velocity. Multiplying 2 kg to 3 meters per second, you can get an answer of 6 kg/meter per second. The positive sign indicates that the momentum is directed to the right, following the direction of the velocity. Always remember that the vector for linear momentum points in the same direction as the velocity. Let us compare the momentum of three identical cars with varying velocities. The first car, which is at rest with 0 meter per second velocity, has no momentum. Observe that as velocity increases, momentum also increases. What causes change in momentum? In this case, change in momentum occurs when the car suddenly stops, resulting from the stepping on the brakes. The stepping on the brakes is an example of impulse. But what is impulse with a symbol small letter I? Impulse is affected by the force exerted on the object and the time the force was exerted. Mathematically, I is equivalent to Ft, or impulse is equivalent to force times time. When the driver steps on the brakes, the driver exerts force on the brakes within a time interval, causing the tires to stop and not hitting the man walking on the street. When impulse is exerted on an object, there is a change in momentum delta P. But what factor affects the change in momentum? The change in momentum results from a change in velocity. Change in velocity may be Vf minus Vi, wherein Vf is the final velocity and Vi is the initial velocity. Since impulse causes a change in momentum, We can now combine the equations for impulse and change in momentum. Change in momentum can be written as the product of mass and the change in velocity, while impulse can be written as the product of F and T. Therefore, Ft is equal to m quantity Vf minus Vi, and that is our equation for impulse change in momentum. Now, how are we going to apply impulse change in momentum relationship? If the change in momentum is conserved, we can identify the relationship between impact force and impact time. Impact force and impact time are utilized in describing impulse. If the impact time is reduced, the impact force is increased. And if the impact time is increased, the impact force is decreased. This is applied in this example. When the boxer is hit by the gloves over a long period of time, the impact force reduces. But if the impact time is short, meaning the gloves hit the face of the boxer fast, the impact force will be great. Another example of impulse change in momentum relationship is when a car hits a wall. The impact time between the wall and the car is too short that the impact force is huge, causing a damage on the car. In order to protect drivers from the result of the huge amount of impact force, bumpers are installed in vehicles to reduce the impact force. Let us have this next example. How can a karate master break the brick? You can pause this video so that you can write your answer in your notebook. In order for the karate master to break the brick, he needs to exert a force over a very short period of time, so that the impact time will be very small and the impact force will be very great, so that the force will be enough to break the brick. Reminder, for more physics videos, you may visit my YouTube channel, Teacher Jackie Teach. Like and subscribe. Have a nice day.